A lesson on straight line graphs, part 1. In this lesson, we will use a graph to represent solutions to an equation. We will look at the definition of an equation. We will use a graph to solve simultaneous equations, and we will see the different types of solutions. Representing an equation with many solutions. The equation 2x minus 1 equals to 3 has only one solution, that is x equals 2, because 2 times 2 minus 1 equals 3. But the equation 2x minus y equals to 1 has two unknowns and has many solutions, such as x equals to negative 1, y equals to negative 3, because this satisfies the equation. X is 0, y is negative 1 also satisfy the equation. And there are many more possible solutions. It is impossible to list out all of them. Therefore, we need to use another way of representing all the possible answers. We use a graph to represent all the solutions. All the previous answer can be thought of as points on the graph, such as x is negative 1, y is negative 3, becomes the point negative 1, negative 3. And all the other points are 0, negative 1, 2, 3, and 3, 5. And we can plot this onto the graph. We can also plot all the other points which belongs to the solution. As you can see that the solutions form a straight line. Hence, all the solutions of the equation 2x minus y equals to 1 can be represented by an infinite straight line. That is, the straight line is the solution to the equation 2x minus y equals to 1. And every point on this line is a solution. We now look at the definition of an equation. An equation is a rule which governs all the points on the line. That is, points on the line satisfy the equation, such as point A. If point A is on the line, such as the point 2, negative 1, negative 1 is 4 minus 5 is balanced. So all the points lying on the line will satisfy the equation 1 equals 6 minus 5. But all the points that are outside the line, such as point B, does not satisfy the equation, such as 3 negative 5. Negative 5 is not equals to 6 minus 5. We now see how we can use this fact to solve simultaneous equations. Solving simultaneous equations using graph. We want to find the solution to these two simultaneous equations. As we know, the points on the line are the solutions to each equation. When we plot all the possible solutions, we will find that there will be one common solution shared by both equations. Therefore, we can conclude that the point of intersection is the solution to both equations. This gives us the answer to our simultaneous equations where x equals to negative 4 and y equals to negative 11. In this example, we see that there are many possible solutions to these two equations. Both lines share the same points. And you can see why this is so. Because these two equations, one is just a multiple of the other. So it is actually the same line. Therefore, the two lines will overlap completely, giving rise to many solutions. In this example, we have two parallel lines. And you can see that the points will never meet. When the lines are parallel, no points will be shared, and hence there are no solutions to these two simultaneous equations. And you can see why they are parallel, because they have a common term in 3x. Next, we see two simultaneous equations. One is a line and the other is a curve. The graphs meet at 2 points. Hence, there are two sets of solutions. That is, at one point, x is negative 0.64 and y is 3.32. At the other point, the answers are x is 3.14 and y is 1.43. Therefore, whenever we have a straight line and a curve, we will have two solutions, two sets of solutions. This completes part 1 of straight line graphs. Thank you.